We will continue our discussion related to the game development with the Arduino. And in the previous stream, we talked about the Simon's gameplay where we need the. So we will continue our discussion, and just like some games which require only LEDs and push buttons. So we have this game which requires only OLED display and push buttons. So basically it also is very simple game, and you can implement it with minimum hardwares. We will be looking into most of the games of Arduino. As you can see, this is an Arduino snake game. What if you implement the game with the Arduino, what kind of concepts that you may think you could learn? Basically, the basic concepts which are required for implementing the games are understanding the basic game theory, and also understanding the concepts of hardware interfacing to make it arcade games. And like this you can create a gamepad. If you had watched different gamepads, it are built with the embedded development, and you know that there is an embedded system inside that game controller. So if you want to implement it, you also need the embedded systems development skills. So that's all that we are going to discuss in today's stream. What you could learn if you implement the games with your Arduino, and how can you excel your embedded system skills with the help of the embedded development, game development. So the game has an input part, a screen display part, and an output or the final gameplay, and then the result screen. If you had watched most of the games, you maybe know there is an splash screen of the game. Let's say for example, if I try to play some game, Let me find out what kind of games I have. Okay, so let's talk about different games. The first game is let's try the Subway Surfer, which is a very famous. Here you have a splash screen. This screen is called a splash screen, and this is a loading screen. After the splash screen, it downloads the assets from the background, and here you can see these are assets are being loaded. So once the assets are there are some dialog boxes. These are the dialog boxes, and some rewards and lot of main menu. This screen is related to the menu screen, where you can select either you want to play the game or you want to collect some rewards and all of these. So this screen is stable, and when you play with it, this is a main gameplay. So here you are playing the game, and these kind of games are, as you may already know, called the infinite runner games, and just like the snake game, where the games is continuous, and the rewards and are the speed and how far can you go, and um, what kind of challenges you can overcome. And this is the collision detection, and the end of the game. It indicates that the game has been ended. Here you can reward user by displaying some ad, and once user click on and play the ad, it will simply reward the user, and it can play another game with it. Let's move on to the Claude, some AI tool, and indicate the core concepts of game development. The core concepts is game loop fundamentals. The game loop is the heartbeat of every game, consisting of the three main phases: input, which reads the user action, and read player's action. So and update, it process the game logic, and render, display the game state. So these are the three main phases of a game loop. Input, taking the input from the user; update the game logic; and render, which is to display the game state. And if you want to implement in a programming, it is this as simple, where you can simply game is running, check if a game is running, and you can process the input, and after it handles the player's input at, for example, reading a push button state, and then update the game, which is to update the game state. For example, if user press the up button, goes the snake will go up. If user press the down button, snake will go down, right, left, and similar, so on and so forth. Then the updated state should be rendered on the screen, or if you are using just simple LEDs, it should be rendered on the LEDs. Whatever a display method you are using, it should be rendered on that. Essential game states. Every game, regardless of the complexity, typically needs three basic states: initialize, which is to load the resources. You have to load some resources from the RAM or the flash or the SD card, wherever you stored the resources. Then set up the initial variables. You need to initialize some variables. For example, you need to load the previous highest score, and you need to compare it with the current score. So you need to initialize the current score with the 0, and then configure the hardware display. And you want to this phase is normally requires you, where you are integrating different hardwares, and you are initializing the drivers. Like for example, if you are using a joystick, you are using initializing the joystick, etc. Then you have main menu. The main menu display the game title. It shows the option to start, change the settings, or exit the game. This is a menu, just like we saw in a Subway Surfer. And then it handles menu navigation. You take it to navigate into different states, and you handle the input and navigate the menu and select the menu. Then you have the actual gameplay, which is a core gameplay mechanics, and you keep the track of scores and level progressions. These are the main phases in the gameplay. As we discussed before, there should be some pause method, where a user can pause the current game state. It frees the current game state and shows the pause menu, and it allows to resume or quit the game. from the pause menu. Then we have a game over screen which displays the final score, option to restart the game or to return to the main menu. So these are the basic essentials of the game states. So if you are implementing a game, you should create these kind of input. So for example, first of all, you initialize the hardwares and you create a menu where user can start the game or change some settings, which is to speed. It could be a speed level of the snake, or it could be a difficulty level, it could be some sound settings, so on and so forth. And the third option should be to exit the game. Maybe user don't want to play the game and just want to exit the game. So from the menu, if user already played the game and the game has been ended, it returned to the menu screen, and then from the menu screen user exit the game. Inside the gameplay, you keep track of a score, you show the score to the user, and you also handle the game navigations and game mechanics, and then the level progression. As soon as user improves its score and plays very well, you have to upgrade the levels. Then you should provide some mechanism to pause or freeze the game, and the user would be able to resume that game or to exit from that state. And then you have a state of a game over, which takes back to it shows how much score user earned, and return to the or option to restart the game or to return to the main menu. Then, as you already read, basic game types and their components, there are some kind of reaction games, which core mechanic could be timing based challenges. So for example, you have to quickly respond to some inputs. For example, tap game where you have to tap and pop, and quick response requirements, you have to quickly respond to the states, and it could be a simple input validations, and this could be easily implemented, and beginners could easily start this game implementing. And key components, it could be a simple LED chasing game, for example the Simon's game, where you show a pattern of the LEDs and you quickly follow the pattern, or whatever LED is turned on, you have to press the corresponding button, and the speed of that LEDs to show up could be fast and fast. As soon as you increment keep progressing, and you can add a simple 7 segment to increment the scores. The key components here is input timing system. You need to implement to keep track to how fast the user give the response. You score based on the reaction speed, how fast the user give the reaction to then some input. You keep the scores, and then you keep in increasing the difficulty curve. Then you have a pattern memory games. These kind of games are the sequence generations, pattern playback, and input verification. You show a pattern and user have to follow the pattern. And the examples could be Simon's case game, and the key components is the pattern storage. You need to learn or to implement the pattern storage, the sequence comparison, and you have to take the pattern from the user and you have to compare the pattern, and then progressive difficulty. Then we have endless runner games. The kind of endless runner games, core mechanics of the endless runner games are the constant movement. So the constant movement, obstacle generation, collision detection, have to constantly move some entity like the subway surfer we just saw, and you have to detect the collisions to that obstacles. So you need to keep track generating the obstacles, you need to detect the collision. And the example is a dinosaur game or a subway surfer game, temple runner game. These are the games which are the endless running games. So the key components you need here to learn is to scrolling background, how you can scroll a background, and how you can spawn the obstacles, and how you can jump or dodge mechanics. So these are the key components that you need to implement if you are implementing a endless runner game. Then we have some puzzle based games which are also some games which are beginner friendly and could give a strong algorithmic skills. And inside the core mechanics are state management. So you have to manage some states of a puzzle, how far the puzzle has been solved, how complex the puzzle is. You have rules validation, so you have to implement some rules for that puzzle to be solved, and you have a solution checking mechanism, and each time you have to verify either that matches the or not. And the example could be sliding puzzles. It is a very old game where you slide the blocks and you have to complete the picture. Or there are many pattern games which are implemented with the Arduino as well. The key components here you need to know is a grid system. You need to implement some kind of grid system. You have to understand or implement the move validation, and you have to know either the user that made a move is valid or invalid. You have a winning condition checking method. So these are the main things which you could learn from creating a puzzle game. Essential programming concepts. So for example, in a pure C programming language, we can implement the states with simple enum. So the enumeration methods allows us to, like for example, creating a state machine for our games, and we can let's suppose we have a menu screen playing paused game over. So we can create an enum for that, which is game state, and we can check that initial state, the current state, a variable could be a menu. So for example, at the start we are at a menu screen. The score system, because the Arduino support the C++, so we have the classes. We have a score system in the class, which is current score and the high score. You add the points, and that points will be added to the current score. And if the current score is greater than highest score, then the high score variable is replaced or updated with the current score. And the basic collision detection system, this is a very simplest or easiest way to check. This is simply if x1 is less than x2 plus width, and this is a simple boundary checking. So this function could be implemented as a collision detection system. Then we have a game design principles, where we need to know that core game loop, and the challenge is what obstacle problems does the player face. We need to implement we have to think about before designing a game, that what kind of obstacles or the problems this player will be face, and the actions what can the player do to overcome them. We need to understand, if we are creating a new game, we are thinking about the new game, we have to think about that, because the game is to overcome the obstacles. So you have to think what kind of obstacles, and user have to take action to overcome that obstacle. So you have to understand what kind of obstacles and how the user could overcome. Then we have a reward section, where we need to know what does the player get from succeeding. So if the player succeed a game, so what kind of reward a user is getting. So this is the main core game loop principles that you have to think if you are creating a new game. then you should add a increasing the difficulty with the animations, effects or audio feedbacks with the sounds, and which let the user know, because user is playing the game, a player is involved with a mental state, and you have to keep its senses active with the sounds and animations, so the user could add its resources of the all senses into the game. That's where the game could be addictive, and user could invest more and more his time on that game. The scores progress indicators, there should be indicators how much user has proceed in that game, and the clear success failure state. This is very important point. You have to implement a clear success, that if user will do this, the user is succeed, and if user do this, the user will fail. For example, if user get collided with some obstacles, the user get lose the game. If the user avoid that obstacles, user are winning that game. And if he increase the high score, user is winning. Or if there is a puzzle, if user solve that puzzle, the user is winning, otherwise user is losing. So you have to make it clear how the user will get successful in that game, or how the user will fail that in that game. So then the common core mechanics, how you can implement a timer system. So you have to implement a timer system if you are creating an Arduino development. That how you can create a timer, it is very straightforward. You need start time, current time, and a game length, how long a game will be. So for example, if the game has a time limit, there should be a maximum number of the game length. So you update a timer, which is simply a millis function. The millis function give you a time tick, and you can subtract the start time, and you have the current time in the millisecond, and you can compare it with the game length. If it is greater than or equal to the game length, then you should display a game over screen. How you can implement a level system in Arduino. You can implement a class with the level, and the current level is 1 and the difficulty is 1.0. You can increase gradually the difficulty, and how you can do that, you can increment a current level with +1, and the difficulty is equal to 1.0 plus the current level multiplied by 0.1. So this is an alpha you can play with, and that is if that will increase the difficulty of the level. Life systems. So if your game has some life, and you have a limited lives, so you can decrement a life every time user lose that life with the lose life function, and you just decrement the lives variable. And if lives is less than equal to 0, then also the game is over. How user can gain the life, if there is some way to gain a life back in a gameplay, you can call this function, which is gain life. And if lives are less than maximum lives, the lives will be incremented, and you have to make sure to check the maximum lives, which is in this case 5. So user can maximum get a 5 lives, otherwise maybe user is getting infinity lives. You don't want to do that, you have to limit the game. So that way you could implement a life system in the Arduino game development. Let's move back to the hackster.io and see what users had created the game, and how we can get benefit, or what kind of concepts we can learn from them. So that way we could be learning how the user will be, or the different concepts related to the game development in the Arduino. Game turn duration timer. So this is a simple duration timer. If you have to display with the Arduino a timer state, you can use this TMA1637 module, and this will be easy. With the only 3 pins you can interface this display, and you can display the time on the 7 segment, and there you have 3 push button and buzzers. So it will simple timer to time your set duration go and playing a game, countdown display and buzzer to signify end of the turn. So just like the way we just discussed that we can implement a timer states, we can use this hardware. And here is schematic diagram. It is simply implemented with the Arduino Nano, and you can use this as a game timer or where you are displaying the countdown time. One more practical examples I came here is, for example, you are creating a game timer for an arcade game which is actually implemented in the game lands, playlands. And this could be implemented. For example, if a user puts a token, it is granted with x number of seconds or minutes, and user can play that arcade game with that x amount of time. So if user put more tokens, user get more time. So that way what you have to do, you have to simply implement a simple and clean push button. That push button will be attached to a coin detector, and whenever the coin will be inserted, you get an active low input on the Arduino pin. You check that pin to be low, or you can implement it with the external hardware, external interrupt, and you check read for that interrupt to go from high to low with the low edge level triggered. And whenever that goes low inside the interrupt loop, what you can do, you can simply update the time with the x amount of constants. And how many times the coin is inserted, each time you get interrupt, and you can increment that time. And similarly, the way we have seen before, you can simply create a timer loop where you can increment and decrement the timer location. So for example, just like in this code, they have a start time with the millis and the timer which is 1000 milliseconds multiplied by duration. And the ul at the end of the 1000, if you don't know about that, it is simply the unsigned long indications. For example, it is forcing the compiler that at the compile time it should know that the 1000 is unsigned long. So for example, when it is multiplied with the duration, it should be a long variable. So if it is not a long variable, it will be rounded, could be rounded down to the integer, so you will not get the actual calculation. So that way you have to attach the ul at the end. So similarly we can select the millis minus start time is less than the timer actual time, and then we have to calculate the elapsed, how many time is elapsed, and we have to show that time. And that's how you can create a simple timer for your games. Okay, so we have a game control using hand gesture recognition. This is a one a lot about the the hand gesture recognition system. And you may be aware that the hand gesture recognition could be a good choice for creating interesting arcade games with the Arduino, where you implement the hand gestures and that hand gesture will be recognized and you are playing some kind of game with it. So as in this project, the game control is implemented using a hand gesture recognition system. So what they are using W5100S EVB Pico and Seed Studio OLED display. And inside that they are using a webcam and breadboard, and with the computer recognition using the media pipe library, they are making a hand gesture recognition. The overall methodology for this is webcam will continuously capture the frames. It will be then analyzed for the presence of the gesture, and each gesture is numbered. Who consider two gestures, and this gesture will essentially move the controllable player gestures to and fro the x-axis, y-axis. Time is also set when the capturing starts. Using gesture controls, a player will be able to catch the randomly generated apples on screen. If a collision is detected between basket and apple, a score is incremented. Once the timeout reaches 60 seconds, a stop control signal is sent and the capture is stopped, displaying the game over screen, and the score is displayed. So this way, all the concepts that we just discussed are come together. You have a gameplay logic, you have a menu, you have a human computer interaction method where you implement some kind of input mechanism. Then you have a game timer, and you have a game over states and collision detection mechanism. So flow is explained. The flow start with the video capture. Each frame is analyzed for gesture using the hand landmarks. So media pipe library is used to create a hand landmarks. What is landmark? Basically, if you closely see in this picture, the red dots are the landmarks. So it will always be these whenever or wherever hands being presented, and hand will be detected and the landmarks will be placed on that. So that will be the hand landmarks detection. If a gesture is detected, it is analyzed to see if it is a high gesture or a fist gesture. So these are the two gestures that is used in this game. Given a particular number, and the number is transmitted via the socket connection. If high gesture number 5 is transmitted, a closed fist gesture number 0 is transmitted. So these are the number 5 and 0. So the get transmission is done in real time with the sockets, and on receiving the coordinates in the visnet pico board, it checks for the presence of a 5 or 0. If 5 is received, the player basket is moved downward, and if 0 is received, they say both in the downwards, but it's a different directions. So they also use the Ethernet UDP protocol to transmit UDP sockets. So this is a demo video how they play it. So this is, for example, the OLED screen where you have a 0. This is where you have a 5, and this is transmitted to the via Ethernet UDP. These two states have been transmitted, and the user is. This is a simple diagram. We can also recreate. So this is the way it is jumping, moving forward and backward. So it is catching these dots. It is a very simple and straightforward game, but it is very interesting. You can also implement this with the Ethernet ESP32 or ESP8266 module. So you can create an interface of a UDP sockets between the. So you can create a ESP32 base module or Raspberry Pi Pico W, which is a wireless module. So you can communicate on a IoT platform. You can create a TCP/IP sockets, but UDP sockets are better. So in a real time, your computer is processing the hand gestures and transmitting the data over a UDP socket, so that the fast response has been implemented. So this need a fast response, or you can simply directly interface your Arduino Nano via USB cable to your computer. So that could not be a realistic state. You need a wireless protocol. It could be very good. So either way, you can take that and you can create this game. So this game is also very user friendly, beginner friendly, and if you already have experience with the hand gesture recognition, you can create this game. You can also find the hand gesture recognition code from this page. They must be provided this code. Let me check in the down below. Yes, you can download this code as a zip file here, or you can check this repository in the GitHub. So this is the repository, and if you open the code, there you have a Python code. In this Python code you have a hand tracking module .py. Let's see this code. You have a class of hand detector, and you are using a media pipe library which can detect the fastest way the hand landmarks. You can use that the detection and find hands. You simply convert the BGR to RGB, and you put that to the processing. And if the result is multi-hand landmarks, if the results is and draw the landmarks, and then you have find positions in the enumeration sections. There you are simply creating a frame detector, then the hand detector, and you read a frame, you find the hand, you find the position, and the length is not equal to 0. You put that in a print, and then you update a time, and you display the FPS, and you put that in simply a text format, how many hands, a fist or 5. So that way it is simply creating a Python code for the hand landmark detection. This is a complete code, and they are creating a sockets. So you have a socket, and then you put a IP address, and the 5000 is a port number, and then you create a sock d grams, which is a UDP sockets, and you set a timeout of 0.07. Then you get the number, and you return that code, and then you capture the video frame, and you set the resolution 640 by 480 for the fastest recognition. Then you create a hand detector, and there you create a date and time, and you check the difference. If the difference is greater than 60, you create a data of stop, and you transmit that data using client socket.send to. So this way you just simply send to a UDP sockets to a broader broadcasting that data, and whoever want to receive that data could receive it on that same port. And similarly you create this further, and that's how the code is being implemented. So that's its very simple and straightforward game. So let's move on to the next one. This game is what we talked in start, which is a beginner friendly. Here you can see the indicator that it is a beginner friendly, and you have a full instruction provided, and this game is check the reaction game. So what this do is you will learn how to make your own reaction game and test you and your friend reaction times. You will be able to tell how fast your reaction time is by getting the LED to stop on green. The further away from the green the LEDs, the slower your reaction time is. So you the I think the gameplay would be something that LED is moving so fast and you have to press a stop button so that LED is whenever come closer to the green LED it will stop. So that could be one way of this. So they provided this schematic and I'm not sure, so they are promoting actually their own website, so that could be the case to implement that game. So you have to make the LEDs will be running, and you whenever the LED come closer to the green LED you have to press the stop button, and if the closer the LED comes the more score you will get. So let's see, here we have this is the catch the light game. So this is also the similar game which we just look. I think they provide this video. I think we talked about this game in the previous stream as well.
This is a Arduino based.
So let's keep it this way. These are all similar games. A space trash game. So this is also a very good game, and yes, it is using OLED display and only two push buttons. So this could be also an interesting game to implement. Let's see how they play this game.
Hello friends, Pipots Maker Hubന്റെ മറ്റൊരു വീഡിയോയിലോട്ട് എല്ലാ കൂട്ടുകാർക്കും സ്വാഗതം. ഈ ചാനൽ നിങ്ങൾ ഇനിയും സബ്സ്ക്രൈബ് ചെയ്തിട്ടില്ലെങ്കിൽ താഴെ കാണുന്ന സബ്സ്ക്രൈബ് ബട്ടണിൽ പ്രസ് ചെയ്യുക. ഞങ്ങളുടെ പുതിയ വീഡിയോ വേഗത്തിൽ ലഭിക്കുന്നതിന് വേണ്ടി ആ ബെൽ ഐക്കൺ കൂടി പ്രസ് ചെയ്യുക.
Up and down, and a fire button. I think the spaceship is firing, and total it makes a total 3 buttons. So that's how they are building. Basically they have 3 buttons, two for going up and down, it will move the spaceship up and down, and the third button is to fire, and whenever user press the fire it creates a bullet, and that bullet hits the obstacle, and there is a collision detection method, and whenever the bullet is closer to that the obstacle are demolished. So this is also very good game for the beginner, and it is also using U8G2 library for LED OLED display, and there they have another video embedded for the final results.
Hello friends, Pipots Maker
I think this is a similar video. Yes. So they just put the video 2 times. So yeah, that's how they are creating this library. If we move down to the code section, let me see what if they have something new that we may want to discuss. I think it is pretty straightforward. So yeah, they have this. Let me move. Racing game. Race the clock in this game of chasing the LEDs. Okay, it says it is a intermediate level player. So the development skills to implement this game, they say it intermediate, but I think this also seems a beginner friendly. The game utilizes a pocket beagle for the program processing, a shift register to control the LEDs, and Adafruit 2.0.56-inch 4-digit 7-segment display with I2C backpack. You can use TM1638 display as well. It is not that you always have to actually copy paste the code. You go on this website and just grab every code and put into your Arduino and see if it is running. Before doing this, just challenge yourself, understand the project, and see what kind of components of that project you already aware of. And if you are aware of some kind of components, just go for there, and from that figure out what kind of components that you don't know, and list those components. And once you aware that these are the components that you are not aware of, before copying and grabbing that components from the project that you are inspired with, you should think how you can replace those components with that components that you are already aware of. What is the closest match, or how you can change the requirement in such a way that it fulfills the final project, but also it helps you to implement it with your own skills. So if you think and if you start the project in such way, it will help you to create the project with your own skills rather than just copying and pasting. Let's see how they play this game. Let's understand the gameplay. User twists the potentiometer to set the difficulty of the game. Okay, so they have provided a potentiometer. So the more lights that are illuminated, the higher the difficulty. And the user press the button to begin the game, and the timer counts down from 3 seconds. The user rapidly presses the button to lead the LED around the track while the timer is running. Once the LED has made it all the way around the track, the final time is displayed. It is very pretty straightforward, and it is very simple game. It is very beginner friendly. Let's see an Alexa skill to answer common questions about the rules of the board game. So this game have some rules. Toss a coin to choose which player is first. Player 1 presses A button on the and press 2. Player 2 press the B button. Press both A and B buttons to show the result of the game. The winner and scores of both players are shown. And this seems also very beginner friendly game. Let me see if they have the video how the game is being played. There's an other maze game which is a beginner friendly, and this is a simple maze treasure hunt written in scratch 2 for the Raspberry Pi using sensat. And let me game is being played. And okay, so this game do not have a video in it, so it creates a simple maze. And let me see if we have what kind of similar projects do we have. um, LED game board project. If you are creating bigger arcade game, you can implement this game board. It requires a lot of components, and you may have to invest a little bit to create this game board. And this is how this LED game board will be working. They have the video attached, and so we can check. Beagle Bone running the server. They are playing. The basic concept of this project was to create an interactive game for anyone that can access a web page. So yeah, they created this simple Pong game. Then they have a winning and losing state. Flappy Bird game. Another one of the most famous game. They are also creating this with the Arduino to send input. So for example, they are playing with the ultrasonic sensor, and they whenever the ultrasonic the obstacle came closer, it basically jumps the bird. So yeah, this way they move the bird using the ultrasonic sensor. So obviously the thing is very simple, and all you have to do is you have to grab some Flappy Bird game, and for the jump button you have to replace that jump button with that Arduino command. So whenever Arduino send command to the computer, it jumps and replicate the keystroke, and that keystroke will jump the Flappy Bird on the screen. So that way you play the Flappy Bird with the ultrasonic sensor. Here they are creating an other Flappy Bird game. This Flappy Bird game use processing programming language. If you are not available with the processing programming language, it is the same language which Arduino used to program the Arduino. So it is closer to C++, but it is not C++. It is a processing language. So the processing language also use Java and as a backend, and you can create some desktop applications with the processing language as well. So that way they are creating a Flappy Bird game with the processing. As you can see, this green interface, they are obstacles, and the yellow dot is the bird. uh, the concept is similar. The reason they use the ultrasonic sensor here is to get the distance data between our hand and the sensor, and use those values to adjust the height of the moving bird. The game is created in processing, and the Arduino communicates with it using the serial port. They linked a few images of the game above, so take a look at them in order to get some idea. So it is very important, and it is a very good project. I think they give you the both of the skills: a gameplay, how to create a game in processing, how to interface your processing sketch with the Arduino via serial terminal, and how to update the game state from the serial input. So this way you get both of the skills. So I think you should give it a try. And learning the code is become very easy nowadays. All you have to do is to put that code in the chat gpt, and the chat gpt will explain that code to you. So I will not go to the details of this. If you are interested enough, you can grab that, and you can learn it from there. So today we are just highlighting few of the games that you can implement with. I would love to discuss this tic-tac-toe game, but for now, I can think of, instead of using the Raspberry Pi, because we are just sticking with the Arduino and especially the Arduino UNO. So I will say that the tic-tac-toe would be implemented using OLED screen as well. So all you have to do is to create a simple grid and use two buttons, so and two LEDs. So whenever the X has a turn, the X LED should turn on and tell the player A to put its selection. So you can navigate between up and down with some two other buttons, or right left if you go with the four buttons. And you can navigate to different cells, which is three cells, 3 by 3 grid. And whenever you are okay that you want to make that selection, you have one button. When you press that button, it will say that okay, you have that selection marked. So that way you can create a simple exo game with the OLED screen and input buttons. So I think the first thing you should try is to create a game, a console. So you have to put a game controller. Inside that game controller, you have four buttons for navigation, two buttons for start stop, and one button could be for pause. All of the game controller buttons that mostly present, just like this, they had created this console. And this console has four buttons for navigating and three buttons for other player input. So you can create this hardware, and inside that hardware you can implement many more games, just like a Game Boy. So let's see, they have a maze game. If you like this, like my stream, it will help me to create the similar content in future. If you want to know more about the algorithm development, the Arduino game programming, or especially the computer vision related things, you can subscribe to my channel. This is some cool, nice animation. This animation is also very good. So that how they are creating a simple game console with one OLED and three and four, seven buttons in total. There are many similar games. This sequence Arduino electronic game, we have discussed that game in the previous stream. Tetris Shield. Yes, this game is also very much popular, and they had created one console with the dot matrix display and few buttons, push buttons, and this way they created a Tetris game, and they created this Tetris game on the dot matrix alone. Pong Yono games, they created this Pong game, and where user could play. And there is another Pong game implemented on OLED screen with the Arduino. Then they have Ninja Dollar game. This is also similar to the what you say, Flappy Bird like game. They use simply the 16 by 2 LCD to create this game. So I think in the next stream I will create a game, or I will put that a video on the my channel. So whatever you like the most, either you want to see me live building a game, or you want to see a stream where, or a video where I just put a video, short and descriptive video about how to implement Arduino based game. Just let me know in the comment section. And as you can see, this game has been implemented. If you like this stream, it will help me to keep creating the content similar. I will be reviewing different projects and giving you the options how to replicate them and how to create them. The today's series is about the game development in the Arduino, so that's why we are talking about the, and see what kind of games a beginner could implement. We already discussed this space trash game using Arduino. We have a focus where user do not need many complex game logics or a complex hardware to create a game. We Our core concept is that users should be able to start the game with minimum hardware and minimum efforts. My future intentions is to implement some kind of computer vision logic to make the games amazing with the human computer interaction, and to put some kind of external hardwares to create an interactivity with the game from the external worlds, just like the arcade games. Okay, this one is not our topic for today, but I think it is some interesting. They use a new pixel sheet, so that's out of this topic. But a touch screen, they created their own touch screen. Let me see what kind of electric paints they use. Electric paints and few of your engineering skills to get the game up and running. So obviously they get the electric glue, and electric paint. They are painted in a paper, and they emulate the touch sensing with it. Paint your sensor. You can use all sorts of sensors for this game. Here's a visual guide that shows you what objects you could use to control the game. You could also design your controller with electric paint. When it comes to designing proximity sensor with electric paint, there are some guidelines you should follow. For proximity sensor here to help you making a controller. We have designed one for you which you can download here. Our game controller gives you easy access to restart the button. Alternatively, you can just design your own sensor. So they are painting the sensors like this. Play the game. To be honest, I have not tested the electric paint, but the use case seems very interesting, and I would definitely like to know more about this electric paint thing. So yes, you can put that paint, and with some simple interfacing of the wires, you can get the sense where user are touching. So that's how they created the electric paint, and the how to incorporate electric paint into graphics. resources. What kind of resources they are sharing? How to write code for the touch board. The touch board can be easily reprogrammed with Arduino IDE, and this tutorial will walk you through. Okay. They are using the electric paint for creating a different kind of creating sensor boards. That is very interesting use case. Moving on, they creating a smart parking system. Parking system is not today's topic, but let give you an overview. They just using an ultrasonic sensor and 3 parking spaces slot. This is not some kind of practical use case, but it will give you proof of concepts that how you can implement a parking system in if you are creating even for the hobbyist project or the demonstration purposes. You need or you have a class project where you want to display the parking system. The 3 ultrasonic sensors are of no use. Rather, if you also want to use a sensor, maybe IR sensor could be more helpful, which will indicate if the closer proximity detection. If the vehicle is nearer, it will indicate that parking slot is full. So they are using maybe the ultrasonic sensor to keep the distance, and this may be assuming that the ultrasonic will detect from farther, but it is a waste of usage and not a practical use case for creating a parking system. So moving on, the Flappy Bird game is a very good game, and I think I will try to replicate the processing sketch for creating the. You don't have to recreate everything. You can just grab that code and you can create some hand gesture recognition to do the flapping. I think that would be interesting. Snake game, pi game. This is a game to help memorize pi decimal expansions. So let's move on further. Game stations. Let's see what kind of game station they are building and what technology they are using in Fenian. So basically, they are using a Raspberry Pi. The video is unavailable, and let's move on. The smartphone game simulator. Play Windows games using gestures. Okay, this project also seem interesting. Let's see what they are proposing. They are saying that you can play the computer games with your smartphone, and the smartphone is used for gesture detection. They are also just reviewing that project, I think. And here maybe they are giving a demo. But here they are using a Raspberry Pi, I guess. Well, let's see what they propose. We'll figure out ourselves. Create a Wi-Fi hotspot without internet access for less latency, and Windows 10 click notification center of the bottom right corner, and click on mobile hotspot using a command prompt. And basically they are suggesting you to create a hotspot, and then you have to download and install IMU plus GPS stream. Okay, so this says that they have a app. I want to check what kind of app. This app isn't available for your device because it was made for an older version of the Android. So I think they created for the older version, and you can use it with the older device. Then you have to buy a 29 USD. Oh no, we don't have to do that. The interesting thing we can grab from this project is we can create an Android app which is detecting a gesture, and that gesture is transmitted to the computer. This transmission method could be wirelessly, just like they created a hotspot on a Windows. We can also simulate the same way, and we can create UDP sockets, just like we discussed in previous project. And we can open up a stream UDP streams, and that packets are broadcasted to the computer, and computer will be listening to that packets on a specific port number which we have transmitted on, and the computer will read that packets, and the computer will respond to that packets, and when wherever the gesture says to move the vehicle, it will move it. So we can create a processing sketch which is easy, and we can create a game, or you can create the game with the Unity as well, and you can interface that inside your Unity games, Unity 3D, which is a very famous game designing game engine. But because our main topic is Arduino based games, so the easiest way is that you transmit your mobile phone gestures via Bluetooth to the Arduino and play the game on the Arduino. But a more interesting thing would be to play the game on the computer. I think that's all for today's stream. I will see you in the next stream. Please leave a comment if you want to know more about, or you want to continue um, learning more about this game development things.